Today I'm going to be going over how to solve the Stratosphere puzzle. This is the box that it came in. The Stratosphere is one of these puzzles that when it's not solved, it can look kind of dangerous, like a sea urchin or a porcupine, something like that, something that's likely to actually physically harm you, but it doesn't really have to be all that intimidating. In this video, I'm going to be going over the characteristics of the puzzle. Which is actually a 3x3, and I'm assuming that whoever's watching this knows how to solve a 3x3, but I'll be going over the characteristics of the puzzle so that you can adapt your style to solving it, and then I'll be providing algorithms for two scenarios that happen when you're solving the final level of it that can mess people up, regarding the centerpiece being 90 degrees or 180 degrees off kilter. And if that's what your problem is, say you've been working this and you've gotten to the last level and you can't figure that out or want to know how to solve it without having to mess the cube up entirely again, then you can go to like the last 5 minutes of this video because I'll be covering that, okay? So the first thing, like I said, it's a 3x3 puzzle. For instance, that's the top level, and there's a front face, there's the bottom level, right side, left side, okay? The actual centerpieces look like this, and if you look at them, it does have a bilateral symmetry, but it also bends kind of like maybe a butterfly shape, such that it is directionally important, so it matters what direction it faces. All right. The next thing you have are the edge pieces, and so there are three types of edge pieces. Okay, so you've got something that's shaped like this, and you'll notice that on each level there's two of these, and they're actually identical. So if you flip this piece, then it's that piece right there, okay? And there's 6 total in the puzzle. There's 2 in the top level, 2 in the middle level, and 2 in the bottom level in order to solve it, okay? The next edge pieces are this guy and this guy. And so if you look at them, even though they look the same, they're actually mirror images. So if you were to switch them, switch the places, they wouldn't fit into each other's spot, okay? And the interesting thing about them is that they look kind of like an N. So if you flip this piece, it ends up, you can flip it and it still stays fitting into its same spot. These guys, not so much so. So what that means is that when you get, say, to the final level and you have one of these that's flipped wrong and then everything else looks right, you can flip this and then reflip one of these, and then you can accomplish, solving the top layer that way, okay? And then these pieces, there's one of these, there's one in this level, one in that level, one in that level, one this level, that level, that level. So there's basically 3 of this one, and there's 3 of that one, and there's 6 of these guys. All right, next thing you have is the corner pieces, okay? So there's 2 types of corner pieces. This thing is a corner piece, okay, and there's 2 of them, and they're on opposite ends of the cube, okay? And then these things are corner pieces as well. So this guy has a trilateral symmetry, so it doesn't matter what direction it faces in the cube, okay? And then these guys don't, okay? So there are 2 of these in the puzzle, and there's 6 of these. And so the top level will have this, and it'll have 1, 2, 3 of those corresponding to corners, and then the same thing on the other side. All right, and so what that means is by the same virtue that if you're flipping corners in the final level, and you've got one, say there's this guy is off, and then everything else looks normal, you can flip this and then reflip that in order to solve the puzzle. So what we're looking here is the center faces, as I mentioned before, they're directionally important. And so as you're solving the puzzle from the bottom up, you have to take this into account. Most people will make a sort of a plus, but when you're solving the plus, you have to account for the fact that these have to be in the right spot, okay? And then from that point upward, you can pretty much adapt pretty much any cube solving algorithms until you get to the top. And then when you get to the top and you solve that, you can find that this centerpiece can be 90 degrees off, it can be 180 degrees off, it can be 270 degrees off, or it can be in line. And if you're simply solving it randomly, there's a 50-50 shot it'll be 90 or 270 degrees off. which can't happen in a regular cube. But I'm going to go over how to fix that right now. So in this scenario, we have a case where the centerpiece is 90 degrees off, and you can tell that when you go ahead and solve the top piece of the puzzle, the top layer, and you can see that the main triangle up there, the one with trilateral symmetry, is at a 90-degree angle to the main edge of the centerpiece. So this happens because the centerpieces are actually entangled with the edges, and so if you have edges that are identical, you can get this problem happening. So the way that you solve this is you take a look at the middle layer, and then you find this edge piece right here where the small edge is at the bottom, and then you go ahead and put it so that this centerpiece is facing you, and then this is the orientation of the cube that you're going to go with, okay? So the first thing you do is, the algorithm for this is you go up 2, you go the front face clockwise, then you go up 2, upper level 2, and then you go right clockwise, then you go up clockwise, then you go right counterclockwise, and then you go up 2, and then you go forward counterclockwise, okay? And so then what happens here is you see that the top level, once again, is all messed up. However, the center face is now in line with this main triangle here, with this main corner. And so when you go ahead and you solve for this top level, then the centerpiece is either going to be in alignment with this, and so you're done, or it's going to be 180 degrees off. And so what I'm going to show you right now is, if when you solve this it ends up being 180 degrees off, I'm going to show you how to fix that. All right, so now I've gone ahead and I've solved this top layer again, and as you'll note, the centerpiece is now 180 degrees off as opposed to 90 degrees off. Now, I'd mentioned before that the centerpieces are entangled with the edges, which is why they can kind of do some weird things. And if you paid attention, what I had actually done was on the top layer, this piece right here, I switched it with this middle layer piece that scoops down. And that's how we achieved moving it from 90 degrees to more of being 180 degrees off. So what I'm going to go ahead and do is do an algorithm that ends up, I'm going to do it 3 times. It changes this piece to that one to that one, and that one to that one. And so every time you do that, it rotates this piece 180 degrees. And so you do that 3 times, it'll bring this piece all the way around and back, restoring the cube, but leaving the centerpiece 180 degrees off from where it originally was. And so the algorithm, as far as how it works, so first thing is going to be you go left clockwise, you go upper level clockwise 1, left counterclockwise, you go upper level 1, you go left clockwise again, upper level 2, and then you go left counterclockwise again, upper level 2, okay? And then what you see is that all these things have been switched, and this is now in the correct orientation. I'm going to do that algorithm 2 more times, and it'll restore the cube to what it's supposed to be. I'm going to speed up the process when I'm doing this. So all right, and now you see that the cube, very hard to hold on to and kind of awkward. You may have noticed while I was spinning it, I got stuck a few times, but it is now solved, and there you go. That's how you solve this puzzle.